our RFID tag, number number 0001315016, and we are going to scan it with our tag reader, and I'm going to show it to you over here, and right there it shows in our computer, and we'll do it one more time.
Your mouse is in the way.
Okay, mouse is on the way.
Okay.
And one more time. There we go. And another time. And another one. And another one. That's it.
Okay, this is the line detection unit that we'll be using for the line following robot. These are 3 color sensors from Avago. And on the back, this is the output. There are 2 output LEDs. One means there's a line in, that's when it's on, and then when it's off, it doesn't see the line. Okay, I'm going to turn it on, and you can see we mounted 4 LEDs on it for a better visual. Okay, and we have a line which is just masking tape over a black background, and you can see that it's not detecting the line yet, and we're gonna slide the unit over, and you can see that the LED to the left is on. That means it's detecting the line to the left. And if we slide it over some more, you see that both lights are on, and that is seeing the line. And if we keep going, then eventually the light on the left is off. That means the color sensor is not detecting the line on the left, but it sees that the line is on the right. If we keep going, then we don't see the line at all. So that's it. Line detection unit. You can see that it could follow the line, and basically for the wheels, these 2 outputs will be going out to the microcontroller that will drive the wheels, so the wheels would readjust if we do go outside of the line. And then that's it.
Autonomous line-following platform. The 2 LEDs indicating is right on the line. By having if it doesn't see one of the lines, it backs up a little bit and it goes forward again until it sees the 2 white LED lights. So it corrects itself. First curve. We're using the reverse as a feedback just to check to keep it on the line.
Mm-hmm.
turn.
Come on, we're almost there.
That completes, or just about completes.
It's gonna try to finish perfectly, straight on the line.
Have it follow the line. Let's start.
Okay, today we will be showing the basic operations of a line scanner. It's a TSL 1401 from Parallax. And this is the basic setup for it. You have it interfaced with the 18 Mega 16. There's going to be two digital outputs, the SI and the clock. And then there will be an analog output from the sensor to the oscilloscope. The first would be the SI on the oscilloscope, second one is just the clock, and the third one is the analog output. Right now we're showing the line scan. It's in this direction, so it should see a valley of just black, and the high means it's white. And as I pull forward where the fork begins, you can see that there are 4 valleys of black and then 3 whites. And if you go back to looking at the fork, you could see that there are 4 prongs on this fork. You didn't show the prong? See? And then I guess if you turn it by 90 degrees, it should, once it's lined up, it's hard to, like, go to 0, because all it is seeing is just black because of the pixel line heading this way. We are right now testing the CMU Cam 2 using GUI software that's available with the camera. First we would go into config, turn on the white balance, and also to make sure that auto gain's on and the camera resolution is high so it's easier for us to see. Then update all parameters. Then we're going to go back to camera view and grab a frame. The camera is right now angled at the grass about 45 degrees with a white line spray painted on the grass. And then if we go and grab a fairly high, we just grabbed a color with red being at 240, blue being 240, and green being up there to 229 with tolerance of 25. And then when we go to color tracking, we can track this color. we can see that the line's in the center. Now, if I move to the left, you can see that it's tracking that the centroid is actually moving to the left. And if you want to see back at the camera view what the camera is actually doing right now, we're going to grab the frame again. And this is showing that the line is to the left now because we moved the camera to the right. And the same would be done for the other direction.
I have one relay connected here, basically. Center button's off, the top button's on. Push the top button, which is on. 3.3 volts, and off.
The line scan, it's in this direction, so it should see a valley of just black, and the high means it's white. That there are 4 valleys of black and then 3 whites, and if you go back to looking at the fork, you could see that there are 4 prongs on this fork. You didn't show the prong? See?
Well, here we got the object detection system, which is the ultrasonic sensor connected to HCS12 microcontroller and LCD screen, which is currently reading in clock cycles, but if you convert it, you'll clearly see that 58 microseconds is per centimeter, and it is 0.125 microseconds each clock cycle, so I'm about half a meter from it. You can also notice here on the oscilloscope how the pulse changes when I move further and I move closer to it, and it is pretty stable.
Just to be able to work on a problem and really do something that's never really been done before and just apply it to a completely new situation is definitely very enjoyable. But to actually come out here and do applied research and actually build a physical implementation of a robot that has to go and really function in any lighting conditions, for example, that we see. It's just something that you would never experience in a classroom. It's a great way to get involved with research at your university, and then to actually be able to see something from concept to completion is a fantastic feeling to see your robot actually go out and mow a course, and it's a fantastic feeling.
It's just a great way to learn. I mean, you go in the classroom and you learn a lot of theory, but to come out and actually practice it, you really do get a very good fundamental understanding of how it works.
And I think this project just simulates very well the idea of a real project out in the real world, working as a real engineer. It's just great because you're taking a very real problem that I don't think necessarily has a solution yet. Just the challenge of looking for the best way to do it, just for me, just made this project very worthwhile.
One of the things I enjoyed the most about the competition was probably just seeing all the machines get to go, you know, all the different unique ways of solving the problem. Obviously there's tons of engineering knowledge that we gain, GPS, laser rangefinder, webcam, vision processing, all of that. On top of all of that, you know, there's project management, time management. As being the team leader, I had to make sure that everybody was on schedule, on time, on budget, and so I learned a lot from that as well.
You can read as many textbooks as you want, you can do all the simulation and modeling on your computer so on, but as soon as you take something in the field, things are going to go wrong. And having students go through that experience and kind of witness it firsthand and overcome these obstacles and actually get out there and compete, I think it's just going to be a huge opportunity for them.
Well, the way I feel after doing these kind of programs, I feel it benefited me in a really positive way. Because not only did I learn like robotics or how to put things together, you can apply these things like in everyday life. I mean, you become really handy. Something fixes, you pull kind of like a MacGyver move, if you would say. You earn a lot of leadership skills from this program, and that's what companies really look for. People who can think for themselves, people who could take command and do what it needs to do to get things done.
This is a great learning experience. This is a great social networking experience. This is something that you can put on your resume, and this is something that you can really learn so much, you know, from the real project that you can put your hands on. It's you know, there is no price for that.
I think companies should sponsor something like this, from just the idea that you're getting better trained electrical, mechanical, software engineers, people working on problems, getting that problem-solving ability way earlier, not just the book knowledge, but the more abstract problem-solving capabilities.
This is probably one of the better interviews a company could do with a group of students. If you get a lot of hands-on access to students, there's 3 days of the actual competition where sponsors are invited to come out and interact with the kids. So I think it's a unique and great opportunity to, you know, recruit potential employees.
I think for the students, the educational value of a competition like this is, I don't think you can measure it. These are the best students that participate in these things. So if you're a potential employer, here's an opportunity for you to get access to some students who already have some skills that are directly applicable when they walk on their job with you day one. They can be productive employees right away.